Welcome to Managerial Accounting. Today we are going to be finishing up Chapter 26, and this is our last day of class before the Thanksgiving recess. So after today, our next class day will be Tuesday, November 29th. But after today, you do have one more big thing you need to do before you consider yourself on Thanksgiving recess, and that is to take Exam 3. So that can really be taken at any time now. That covers through Chapter 25. You should have already completed all of the materials, all of the requirements, assignments up to that point. So go ahead and take Exam 3 whenever you're ready. Don't forget to open the ebook. We talked about the exam and the practice set on Tuesday. So that appears at the beginning of the recording from Tuesday's class. So if you do need to take a look at that, feel free. If you are working on the practice set and have questions, I'd be happy to help you with those. We didn't have a review session for this exam, and so there isn't a recording of going through those practice set exercises. So if you do get stuck on anything, please just let me know and I'd be happy to help. So our task for today is to finish up Chapter 26 on capital investment analysis. Last class we covered the accounting rate of return and the payback period method, and then we had begun work on the net present value method, done a couple exercises, and at the end of class we were working on this one, which is exercise 5. We had done most of the exercise, but we ran out of time and I was trying to hurry through it at the end, and I may have even said something, put something on the screen or said something that mathematically didn't make any sense because I was trying to hurry. So I should never do that. We are going to start part D right now, and I'm going to go through the calculation on the screen, excuse me, starting from scratch and not trying to rush through it. So I want to start with our answer here though to part B. So part B, we determined that the net present value of all those future cash flows associated with this project would be $142,163. And we said, yes, that's a project we should undertake because it exceeds the amount to be invested, that upfront cost of $125,000. And part D says, okay, where's kind of the break-even point? So how many hours, we're estimating that we're going to work 1,000 hours. How many hours would we need to work to make sure that we were at least breaking even, to make sure that this investment was a good idea? And so I'm going to pull up that table, maybe. Where's the table? Oh, sorry, there's the table. So I was trying to click on that thing that's not a link. So the factor that we had used to calculate that $142,163 was based on the desired rate of return of 10% and the, where is it, 5 years. So, and the time period for this investment. So 5 years and 10%, the factor that we used was this 3.791. Okay, so keep that in mind. That is where this 142,163 came from. And let me get my annotate up here. And so this is basically the calculation that we're looking at. We want to know what is equal to this 125. And we're looking for the net present value of these future annual cash flows. And the future annual cash flows are based on this that we did at the top, which is the kind of the income statement or the cash flow statement for this investment. And so it was $90 per hour was the revenues times the number of hours. And we subtracted from that the expenses of $45 per hour. I'm going to put a $ here also just to be clear. So $45 per hour for the variable cost, time the number of hours, minus that fixed cost of 7,500. And so what's in that parentheses now is the annual cash flow associated with this project. $90 in revenues minus $45 in costs for each hour that we work, minus the 7,500 fixed cost. And we want to know for that annual cash flow, if we discount that back to present value using the factor that we found in the table, what would the number of hours need to be to make it equal to the upfront investment? And now you can see why I was trying not to do this the long way, because that is a much longer formula than certainly that I had time to work on during class on Tuesday at the very end of class. So I was thinking I could make it a little faster, but I was not successful at that. And so I'm just going to go about using algebra to solve this equation. So I'm going to divide both sides by 3.791. So now on the right-hand side, I have $90 times hours minus $45 times hours minus 7,500. And I'm going to combine a couple steps here. So I'm going to do 125,000 divided by 3.791. And that gives me, whoops, that gives me 32,793 rounding off. And I want to subtract 70. Well, I don't want to skip over too many steps in case people are trying to follow this. So I'll just use 2 decimal places there. Hopefully that's going to be close enough on rounding. So 90 times hours minus 45 times hours would give us 45 times hours left. And minus, whoops, 7,500. So then if I add 7,500 to each side, I now have on the left-hand side 40,472. Whoops, typo. 40,472.83. And on the right-hand side, I have 45 times hours. And so now if I just divide each side by 45, I'll get hours by itself. And so hours equals 899.4. And let's see what it asks us. It asks us to round interim calculations and final answers to the nearest whole number. And as I suspected, I did end up with a bit of a rounding issue here. So I came out with 899.4 because I didn't really follow the directions, because it says to round the interim calculations to the nearest whole number, and I didn't do that. I kept the cents on here. So 899.4, but if I had rounded off back here, the 32,972.83, if I'd rounded that up to 32.973, I'm just going to recalculate this. 32,973 minus 7,500 divided by 45. Whoops, sorry, 32,973 plus 7,500 divided by 45. Yeah, so if I had rounded off the way the exercise suggested we should, it actually would come out to 903 hours. So I still ended up with a rounding issue, unfortunately. But is everyone okay with the basic calculation, even though I failed to follow the directions as far as rounding? Everyone okay with that? Okay. So, and I can tell you, because I'm looking at I'm going to call it the textbook solution for how they did this calculation. Because I was trying to figure out where I went astray from what their rounding was. And the way they did it, they set it up the same way I did, except instead of dividing each side by 3.791, they distributed the 3.791 to each of these terms and then rounded each of those off. So that's why their answer is a little bit more, it's 3 hours off from mine, because they did some extreme rounding here that I just didn't do. So, excuse me. So if anyone watching this or here live is thinking, oh my word, but if it's self-grading, what am I supposed to do when I round it? I did this, set it up just a little bit differently and rounded it differently. If that were to happen on the exam, and it won't, I don't think there's a situation like this, but if that were to happen on something that's graded, I would just suggest that you reach out to me and let me know that, hey, here's what I did. Here's how I did the calculation, and, rounding threw it off, because obviously the self-grading like this, I wouldn't necessarily see that my answer 899 is obviously really close to the 903. And it makes sense that would be rounding, but I wouldn't necessarily see that unless you bring it to my attention. So if anyone's worried about that, oh my word, rounding is a problem, you just need to, bring that to my attention if it were to happen. And like I said, I don't think it will. So clearly I could not have fit that into the last 2 minutes of class or whatever it was we had left on Tuesday. So it's a good thing I gave up trying to fit it in. And let's keep going. Let's move on to our next exercise, which will allow us to practice a little bit more with net present value calculations and introduce the present value index. It says Diamond and Turf Incorporated is considering an investment in one of two machines. The sewing machine will increase productivity from sewing 150 baseballs per hour to sewing 290 per hour. The contribution margin per unit is $32 per baseball. Assume that any increased production of baseballs can be sold. The second machine is an automatic packing machine for the golf ball line. The packing machine will reduce packing labor cost. The labor cost saved is equivalent to $21 per hour. The sewing machine will cost $260, have an 8-year life, and will operate for $1,800 per year, 800 hours per year. The packing machine will cost $85,000, have an 8-year life, and will operate for 1,400 hours per year. Diamond and Turf seeks a minimum rate of return of 15% on its investments. And so the first thing we're asked to do is determine the net present value for each of the two machines. Use the table here to discount those future cash flows back to present value based on the 15% expected rate of return and the 8-year life for each of the projects. Okay, so I'm just going to make a note here that the present value interest factor for the annuity that we're going to use based on the 15% return and the 8-year life of these projects, the factor that we need is 4.487. And that's right here in the table, 4.487, 15% in 8 years. I wanted to make a note of that so I can scroll down and not have to, hopefully not have to keep scrolling back up and down to get the rest of the information. Except I do want to give myself lots of writing room. Excuse me. So let's start with this sewing machine. So we know for the sewing machine, the upfront cost, the amount to be invested, the sewing machine will cost $260,000. And the packing machine will cost $85,000. But we then need to calculate what the annual cash flows are expected to be for each one of these projects. So we'll start with the sewing machine. And for the sewing machine, it said that we will, if we have this sewing machine, we can sew 290 baseballs rather than 150 baseballs. So 290 rather than 150. The marginal product of this sewing machine is 140 baseballs per hour. Okay, so this sewing machine, if we buy it, will increase the baseballs we have available to sell by 140 baseballs per hour. The problem went on to tell us that we would use this sewing machine. Where is it? The sewing machine will operate for 1,800 hours per year. So 1,800 hours, and each one of those hours produces 140 baseballs. So 1,800 hours times 140 additional or marginal extra baseballs per hour, we will have an extra 252,000 baseballs to sell each year. And each one of those baseballs will contribute 32 cents in contribution margin. So that means after we cover the additional variable costs of producing those baseballs, we will have 32 cents left over that goes straight to the bottom line. So 252,000 baseballs at 32 cents each. Our extra revenues. Whoops, how did I get there? Sorry. Here we go. 80,000. So our extra profit for the year based on the information that's provided would be $80,640 per year. And I already looked up the factor, 4.487. So discounting that $80,640 every year for the next 8 years, discounting that back to present value by multiplying by that factor, 4.487. And that gives us, we're asked to round to the nearest dollar. That gives us annual, the present value of all those future annual net cash flows of $361,832. Comparing that to the upfront cost of $260,000, and the net present value or NPV of this project would be $101,832. Everyone okay with that? Okay. So let's look at the packing machine then. And I'll put that down here. So the packing machine. And what are we told about the packing machine? Let's see. The packing machine will reduce labor cost, equivalent to $21 per hour. So it's a $21 per hour savings, and the packing machine will run for 1,400 hours per year. So 1,400 hours per year, saving us $21 per hour. The annual increase to our cash flow would be $29,400 from the packing machine. So not as lucrative as the sewing machine, but remember the sewing machine also costs a lot more. So 29,400 multiplied by that factor, the present value interest factor for the annuity, 4.487, multiplying that, we get a present value of those future cash inflows of $131,918, rounding off to the nearest dollar. And that gives us a positive NPV of $46,918. Okay. So looking at this, just looking at what we have right now, do we know which of these products is the better deal? And the answer is no, because the upfront cost for these projects is not the same. So we know that the sewing machine will make us more money over the 8 years, but it also is going to cost more than twice as much. It is 3 times as much for the sewing machine as the packing machine. So part B gives us another way of looking at this to make this decision. The assumption is that the company, it has to decide between these two products, right? The assumption I'm going with is we can't buy both the sewing machine and the packing machine. If we do have the funds to invest in both of these, to spend, $345,000 on capital investment, then our answer at this point would be, sure, these are both good projects. They both have a positive NPV. Remember, we said on Tuesday, as long as that NPV is greater than 0, it means that it's covering the required minimum, which in this exercise was 15%. So in order to undertake a project, it said right there, minimum rate of return of 15%. So the fact that these both have a positive NPV tells us they're both have a return of greater than 15%. Those are both acceptable based on our criterion of 15%. But if we don't have the money to do both, how are we going to decide which one of these is the better deal? And the way we can do that is by using the present value index. I'm going to go ahead and clear my drawings off the screen. And so to calculate the present value index, I'm going to give you the formula here. I'm just going to abbreviate it, present value index, PV index. We take the present value of the future cash flows, put that in there a little better, and we divide that by, over here, we divide that by the upfront investment, or the cost of the investment, however you want to think of that. So for the sewing machine, we would take the $361,832 that we calculated in part A, right here. We would take that and divide by the $260,000 upfront investment. And it asks us to round to 2 decimal places, so that would be 1.39 for the sewing machine. Go ahead and do the same calculation for the packing machine. And so the packing machine has a present value index of 1.55, the sewing machine 1.39. If you wanted to think of it like this, you could say for every dollar invested in the sewing machine, it returns $1.39 in present value of those annual net cash flows. Okay. In present value, the present value of the sewing machine investment is 1.39 times the upfront investment. In other words, we make 39%, right? And the packing machine has a present value index of 1.55. We're making an additional 55 cents in present value terms on every dollar invested in that packing machine. So if we could only fund one, and the qualitative factors are equal between the two machines, that is, that term I've given you before, ceteris paribus, that economics term, which means if everything else is the same, and we're just talking about which one of these is financially the better deal, which one would we invest in? And it would be the packing machine because it has the higher present value index. So that present value index gives us a way of comparing two projects that maybe have different upfront investment, upfront costs. Any questions about that exercise? Okay. So our next exercise is asking us to use all three methods that we've covered up to this point: average rate of return, which I also call the accounting rate of return, cash payback period, and the NPV method. And as I usually like to do, this is for a service company, so you can see that the concepts that we're covering here when we talk about capital investment can easily apply to other types of companies. This is not just for manufacturing companies, even though that's primarily our focus for this semester. Spanish Peaks Railroad Incorporated is considering acquiring equipment at a cost of $1,250,000. The equipment has an estimated life of 8 years and no residual value. It is expected to provide yearly net cash flows of $312,500. The company's minimum desired rate of return for NPV analysis is 12%. Don't know where that half came from. 12%. So we're first asked to calculate the average rate of return. So I'd like you to just try this on your own, and I will put mine on the screen. But try the average rate of return method on your own. Okay, I need to change this because that's our cash flow. I'm just looking at the. And so the number that was given to us was, they didn't actually give us the accounting income. They gave us the cash flow. As I look at the exercise, 312,500 is the cash flow. And so if we use straight line depreciation, so remember the other, so the $1,250,000 with no upfront investment, with no residual value, we're going to take that 1,250,000 and divide it by 8 to find the annual depreciation. And by doing that, we can change the annual cash flows, which were given, into the accounting income, because we're subtracting that non-cash expense. So 312,500 minus 156,250. So that leaves us with 156,250 for accounting income. Yep. And that makes our accounting rate of return 25%. So I had asked you to try that on your own. Hopefully you came up also with 25%. If you have a question on that, certainly can use the chat or unmute and ask a question. But as we covered it on Tuesday, the average accounting rate of return is the accounting income divided by the average investment. So I found the average investment first, the upfront cost plus the residual value, which in this case was 0, divided by 2, gives us the average value of the investment throughout the life of the investment. That is the denominator of the second equation. The numerator is the accounting income. And so I had to take that cash flows that were given and change it into accounting income by subtracting the straight line depreciation. Okay. Part B is for the cash payback period. And so since we do have that the same cash flow predicted for every year, that annuity concept that we've talked about, the cash flow for each year is projected to be $312,500. And if we divide that, since we do have a constant expected cash flow, we can take the upfront cost, divide by that annual cash flow, and purely coincidentally, it works out to exactly 4 years. It would take us 4 years to get our money back from that project. For both of these two methods that we did, first, average rate of return and cash payback period, we know that one of the drawbacks, the disadvantages, is they don't take into account the time value of money. Cash payback period doesn't take into account the residual value of the asset, doesn't take into account anything beyond the first few years until you get your money back. So you're really only looking at a subset of all of the cash flows associated with the project. And they don't take into account the time value of money, which makes them a little bit less reliable, especially as we start talking about cash flows that are happening out in the 5th, 6th, 7th, 8th year. The longer you have to wait for those cash flows, the more significant that is in our calculation. And so finally, let's look at the net present value method. So for the net present value method, we are taking into account, of course, the time value of money. And we are looking at all of the cash flows associated with the project. So if this asset had a residual value, we would also discount that back to present value. We would assume we'll sell it to get that residual value as an added cash flow at the end. But because there is no residual value, the only cash flow that we have to discount is the yearly net cash flow of $312,500. And that's over 8 years. And the minimum desired rate of return is 12%. So if we go to the 12% column and go down till we get to 8 years, and you can see the factor there is 4.968. If we multiply that 4.968 by the annual cash flow, $312,500, the net present value of those future cash flows is $1,552,500. So just to show you the total cash flows, if we disregard the time value of money, the total cash flows would be $2.5 million. So if we disregard, if we ignore the time value of money, we have a total in nominal dollars. We have a total of $2.5 million that are going to come in from this project. But we have to wait 1, 2, 3, up to 8 years to get those cash flows, so they're not worth that much to us today. When we discount them based on the 12% expected rate of return, we have a present value of all those future cash flows of $1,552,500. Then we can compare that to the upfront cost, which was $1,250,000. And so I find a positive NPV, or net present value, of this project of $302,500. So this exercise does not ask us to, but of course, the only reason we're doing any of this is to help us make a decision about, is this a good project? Is this something we should undertake? And based on what we have here, I can only answer that using the net present value. And I can say definitively, because there is a positive net present value, and this is, highly positive, we would say, yeah, this is a good deal. We should consider this project. For the first two, average rate of return and cash payback period, I can't tell you whether those are acceptable. As I explained on Tuesday, the company would need to set in advance, what their success criteria would be. So if they're using average rate of return, they'd have to say it must be at least 20% or whatever number for us to consider that investment. And for the cash payback period, they would have to say, we must get our money back in no longer than X number of years. And I don't know, maybe it's 2, 3, 4, I don't know. But we can't, for A and B, the company has to say, here's what's acceptable. If you're wondering why I'm not saying we need that for Part C, we have that information right here. It tells us the company's minimum desired rate of return is 12%. We already know that. And so we've built into the model, we've built into the calculation already what our success criteria would be. It must be at least 12%. The factor that we used is based on that 12% return. The fact that we end up with a positive NPV at the bottom tells us that the return is more than 12%. If the NPV was exactly 0, that would mean the return is exactly 12%. So anything greater than that, we're good. We're happy with that. But I can't draw that kind of a conclusion for the first two methods because we're not provided with that success criteria. Any questions on those three methods? All right, so let's go to our final method. Whoops. I have no idea what button I just pushed. I'll try that again. Okay, so let's go to our final method for this chapter, which is the internal rate of return method. So as I explained to you on Tuesday, I'm kind of calling this another half method because it really is kind of a version of the net present value analysis. We kind of turn it around and do it backward. So rather than looking at the future cash flows and discounting them back to present value and saying that's good enough, we look at, here's what the upfront cost is, how much would we have to get in those future cash flows to make it worthwhile? So it's really looking at it in exactly the opposite approach as what we use for net present value. And for our purposes, because we're going to be using the table just like we did in for the NPV method in the last couple exercises, we're really going to be doing what's called interpolating. So you might think of it kind of like a guess and check, or we're going to find a number in the table that comes closest to what we're looking for. And we're going to look at exercise 8 in just a moment to let you see how it works. But basically, this is what we're doing. So we're looking at here's the upfront cost. How much would we have to get in those annual cash flows over the length of this project to make it worth it for us? And then we look in the table to see, so what does that mean? What would that factor be? Okay. So here are the steps that we are going to follow in exercise 8 in just a moment. When there are equal annual net cash flows to be expected from the proposal, we're first going to determine, you may, if you're writing down notes, you may want to make a note of this formula that's right here in the middle of the page in step 1. So we take the amount to be invested, we divide it by the equal annual net cash inflows to determine what that present value factor would be. And then we go to the table and we find that factor in the table and then say, is this good enough? Okay, so the important part for now, and we're going to go look at our first example, is the formula here in step 1. The amount to be invested divided by the annual net cash flow. If the annual net cash flows are not equal, it is really beyond the scope of this class for us to be able to use this internal rate of return. We need to be able to use the annuity table to make this work, unless it's just one single cash flow. So we really need to be able to use the annuity table. We have to assume, or we can only use this for projects or proposals that have equal annual net cash flows. So let's go to our exercise, I think. And then we'll come back to this. So let's go to our exercise. The internal rate of return method is used by Testerman Construction Company in analyzing a capital expenditure proposal that involves an investment of $113,550 and annual net cash flows of $30,000 for each of the 6 years of its useful life. So with that formula that I just showed you, the present value factor associated with this project would be the upfront cost, $113,550, divided by the annual cash flow. $113,550 divided by $30,000. And I got a factor of 3.785. Everyone okay with that? And so we know this is a 6-year project. So I know I'm going to be coming down to this row. That is the 6-year row. So I'm looking just at what's in this row right here. And I want to find the factor that comes closest to what we just calculated, 3.785. And miraculously, as it turns out, that 3.785 is one of the numbers in our table. Now, in reality, it frequently might be something between two numbers. We might have to what I call interpolate. So interpolate is the opposite of extrapolate. People are more familiar, I think, with the term extrapolate, where you have a set of data and you project or predict outside of that data set. Interpolate means we have data and we're going in between them. So between the two numbers. So we're very lucky in this case that the factor that we calculated is exactly in the table and it corresponds with that 15%. So I just want to go up the table and see there's our 15%, and that's the answer. So the factor was 3.785, and the internal rate of return for the proposal then would be the 15%. Okay, at the top of that column. So this is a little bit less precise than what we did with net present value calculations. The problem, as I just pointed out, is that you may not have the factor show up exactly on a figure. The other reason that I'm troubled by the internal rate of return approach is, unlike what I've just finished talking about with the first three methods, where I said the company has to decide up front what's acceptable and then do the calculation and see if it matches. To me, internal rate of return somewhat feels like we're saying, the return would be 15%. Is that good enough? And kind of deciding retroactively if we should accept this project, where I think they should decide up front, here's what's acceptable. Okay, did we get it? I just have a feel, it feels to me like you might make a decision after the fact and say, yeah, okay, that's good enough. But I think that decision should be made up front. Okay, so this method also, of course, depends on having a table like this. It also, and let me go back to the advantages and disadvantages here. So if we don't have a regular annual cash flow, what we just did would not work. It becomes very complicated. So you certainly could program a computer program. You could even do it in Excel to kind of do a guess and check for you to do those calculations. But it's a little bit more challenging. And so I'm not as big a fan of the internal rate of return method. It does have advantages over the payback period and accounting rate of return, because it does include that present value or time value of money concept, which is very important, especially for longer projects. It does include all of the cash flows over the life of the investment, including if there was a residual value, would take that into account. But again, with what we are doing, it would be difficult to take the residual value into account, because we've said they have to have the same cash flows every year to do it the way we just did. So it is a little bit more complicated. Okay, any questions about internal rate of return? Okay. So exercise 9 is two different internal rate of return calculations. And I think to let you try this on your own, I think after we read through this and kind of talk about what the calculation will be, I'm going to pause the recording and let you try these on your own. So Munch and Crunch Snack Company is considering two possible investments, a delivery truck or a bagging machine. The delivery truck would cost $43,056 and could be used to deliver an additional 95,000 bags of pretzels per year. Each bag of pretzels can be sold for a contribution margin of 45 cents. Delivery truck operating expenses, excluding depreciation, are $1.35 per mile for 24,000 miles per year. The bagging machine would replace an old bagging machine, and its net investment cost would be $61,614. The new machine would require 3 fewer hours of direct labor per day, saving us $18 per hour. There are 250 operating days in the year. Both the truck and the bagging machine are estimated to have 7-year lives. The minimum rate of return is 13%. However, Munch and Crunch has funds to invest in only one of the projects. So we can see the revenues and the cost for each one of the projects. So at this point, I am going to pause the recording, ask you to complete this exercise, and you certainly then can use the check my work button, restart the recording, and I will quickly walk through my calculations that I'm going to put on the screen, but try to answer both of these and then restart the recording if you need more help with that. Okay, so before I scroll down, I just wanted to show you my calculations here. So for the delivery truck, we're going to have a marginal increase of 95,000 bags to sell with a contribution margin of 45 cents per bag. So our additional revenues would be $42,750 if we bought the delivery truck. But our additional cost would be the $1.35 times 24,000 miles, or $32,400 in marginal cost. That gives us a net cash inflow of $10,350 per year. If we divide that into the upfront investment of $43,056, we find a factor of 4.160. This is a 7-year project, so I have highlighted here this 7-year row, and 4.16 is right here lining up with the 15% internal rate of return. The bagging machine would save us 3 hours of labor a day at $18 per hour times 250 days a year of operations, with an annual net savings of $13,500. Divide that into the upfront cost of $61,614, and we find a factor of 4.564, which is right here, lining up with a 12% internal rate of return. And so if I go down here and plug those in, the delivery truck was 4.160, the bagging machine was 4.564. And those equate to 15 and 12% respectively. So the bagging machine's rate of return was less than the minimum requirement of 13%, while the delivery truck rate of return was greater. Therefore, the recommendation is to invest in the delivery truck. So hopefully you got those okay on your own. Green check marks in there. And if there aren't any questions, we're going to move on to our final exercise for today. Bunker Hill Mining Company has 2 competing proposals, a processing mill and an electric shovel. Both pieces of equipment have an initial investment of $750,000. The net cash flows estimated for the 2 proposals are as follows. And we're given the table there of the net cash inflows. And so you can see that the electric shovel is expected to last only for 4 years, while the processing mill would last 8 years. When we have unequal lives, one way of comparing these is to only look at the part, only look at, in this case, the first 4 years. Only look at the portion of the proposal that would be an equal life. Okay, so if the electric shovel only lasts 4 years, then we should look at just the first 4 years of the processing mill, including what would be left of that processing mill at the end of year 4. So even though we know that it could be used for an additional 4 years, what if we cut off the project at 4 years? What would the end result of that processing mill be? And then we're told that at the end of the 4th year, the processing mill would still have a value of $280,000. So we're asked to determine which equipment should be favored, comparing the net present values of the 2 proposals, and assume a minimum rate of return of 15%. Use the present value table appearing above. If required, round to the nearest dollar. And so what we're going to do is, for each of the projects, we're going to look at just the first 4 years. You can see that these do have irregular cash flows, so we cannot use the annuity concept. So we actually need to discount each one of these back to present value, one cash flow at a time. We are told that both pieces of equipment have an initial investment of $750,000. It does not tell us anything about the residual value for the electric shovel. So I'm going to assume that the residual value is 0. In reality, I'm going to say that's probably not true. And so if there was a residual value for the electric shovel, we would need to know what that was, and we would also discount that back to present value. So using the table, I am going to just fill in, I'm just going to make, kind of stick an extra column in here just to make this a little bit easier for us. Maybe I'll put it over here. Again, to avoid the scrolling up and down, I'm going to pull in the present value interest factors from the table that's below on the screen. So we're told that the two proposals are, that we have to assume a minimum rate of return of 15%. So in that present value factor table that's down below, I'm looking at the 15% column, and starting at 1 year, the factor is 0.870. Year 2, the factor is 0.756. For year 3, the factor is 0.658. And for year 4, which is as far as we are going to go, the factor would be 0.572. And so now I'm going to create 2 more columns to actually do the present value calculation for each one of these. So for the processing mill, $310,000 in cash flows the first year, discounted at 0.87. The net present value of, oops, that should be a comma. But net present value of the 310,000 is 269,700. For year 2, 260,000, discounted at 0.756. And go ahead and do year 3 and year 4. And I'm just going to stick another row kind of in here, because the processing mill, although it could continue to be used, we want to compare the projects of equal duration, of equal lifespan. And so I'm going to take that residual value of the processing mill at the end of year 4, $280,000. That's down right at the bottom of the screen here. And I'm going to discount that using that same factor from year 4, 0.572. And so if I were to add all of those together, we would get JCC is calling me. I'm guessing that some of you are also probably getting an alert from JCC right now. Something probably related to the weather. All classes, activities, and offices at all locations of Jamestown Community College will resume. Remote operations is at 6 a.m. on Friday, November 18th, 2022. Okay, so we're already on remote operations for this class. And so if you didn't just see that, no on-campus classes for tomorrow. Everything is going to remote operations. So you will be if you have classes on Friday, they will be based on what your teacher for each one of those classes has determined. So looking at the electric shovel now, discounting each one of those back to present value. So starting with the $330,000 times the 0.87 factor. And I got 287,100. And for year 2, 325 times 0.756 has a present value of 245,700. And if you go ahead and do those for year 3, oops, 213,850, and then for year 4. And finally, as I already pointed out, they didn't tell us anything about a residual value for the electric shovel. So I'm assuming that there is not one. If there was, we would discount that just like we did for the processing mill using the same factor from year 4, the end of the project. Oops, 929690. Yep, that's it. Okay. So any questions about where those numbers came from? 946,220 and 929,690. So I'm going to just scroll down here, ignore my blue if you would please. And we're going to plug those numbers in to the table. The amount to be invested was the same amount for each one of the projects. That was $750,000. And so we can calculate the net present value. So I would just like to point out that something in this exercise is, when we talked about in the earlier chapter about differential analysis, and we said we can ignore costs and expenses and revenues that are not different between the two projects. So if you're thinking about that, hey, wait a minute, she said if the amounts were the same, we didn't even have to pay any attention to them. That's a little bit true. And so this line for the amount to be invested, the cost for each one of these pieces of equipment is the same. And so we still need to take it into account for this present value calculation, because it is telling us whether either one of these has or both have a positive NPV. And so that's why it's included here, so that we can clearly see, yes, both of these are good ideas. Both of these are projects that would return a positive NPV, would return more than the minimum requirement of 15%. If the question was, hey, we need to buy one of these things, we have to have one of them, then I would say in that case, it doesn't matter if it's a positive NPV if running your business requires one of these items. And in that case, we could disregard the 750,000 as not being a different, differential piece of information. But we do include it here because ultimately for this question, this decision, we are trying to decide if either one of these is a good investment. And it turns out both would be reasonable investments returning more than the 15%. But if we can only do one, it should be the processing mill. we have the money to do both, we should go ahead and do that because they are both positive NPV projects. And so that is the end of our coverage of chapter 26. Anyone have any questions, anything you want to talk about? I'm going to stop the recording.